This is 5.3, and today we're going to start actually solving trig equations. And at first it's going to look kind of muddled, like there's a lot going on, but if you really step back and just kind of look at the equation, you might find that you know where to start better than you thought you did. So if you were looking at this and you were trying to solve for x, most people would tell me you're going to add 1. So 2 sine x equals 1. Then most students, if I asked them what would happen next, they'd say, oh, I'd probably divide by the 2. So sine x equals a half. So it's not really as bad as it looks at first glance. We're going to get into some tougher ones as the problems go on here. But really the whole idea is for you to get the x by itself. So using your basic algebra skills from, second grade, that's what we're doing here. So the last step is really asking you what angles have a sine of a half. So we're kind of doing this, and we're saying what angles have a sine of a half. And so this is where you pick up your unit circle and you start looking for all the places where the y value is a half. Found one already. Y value is a half right there. Looking for another one, and there I found it. There will usually, always, be 2 answers that you were looking for. If I keep looking, these are actually negative half, so they won't work because we're dealing with a positive half. So my 2 answers are 30 and 150. You can also use the radian measures as well. Degrees or radians, it doesn't really matter what you give me for an answer. Next problem, number 2, we're going to subtract that 1 first. So I have negative 2 cosine x equals a negative 1. Dividing by negative 2 on both sides, I end up with a half, so kind of the same as the last problem. So I'm looking for all the angles that have a cosine of a half. So looking for x values of a half. I find it at 60. And that's a negative half, so that won't work. And that's a negative half, and here's a positive half. So 60 and 300. The next problem has 2 trig functions, which is not helpful, and they're on opposite sides of the equal sign. So our job will be to first just get them on the same side. And you can move trig functions just as though you were adding a 1 to both sides, or if you were just having an x there, if you were adding x to both sides. So I'm going to add that sine x over to this side. And if I have a sine x and I add it to another one, I end up with 2 of them. Not squared, because we're not multiplying, but this is just adding it over. So now I'm going to minus a 1 and divide by 2, kind of in one step here, minusing the 1, dividing by 2. And now I'm going to look for places where the sign is negative half. So looking at my unit circle, looking for places where sine is negative half happens at 330 and 210. Next one, I've got a tangent, and it's squared, so it kind of just changes our game a little bit. Still going to take the 3 over to the other side, which will kind of hopefully be routine. And then in order to get rid of the squared, we'll have to square root both sides. So I'm looking at tangent x equals plus or minus the square root of 3. Remember that when you square root both sides, you have to add the plus or the minus in there. And now what you're looking for, all the places around the circle where you have a tangent of plus or minus the square root of 3. And again, on your circle, hopefully you have all the tangents written in, so you don't have to do any figuring out right now. You're just looking and picking them out. And since I am doing every plus or minus, that means I'm going to have 4 answers, not just the normal 2, because usually we're looking at just the plus values or the negative values. But since we're doing both of them, I should end up with 4. And my square roots happen at pi over 3, or 60, 120, 240, and 300. So listing out all of those options. Next one has got a whole bunch of trig functions happening. Again, we want our trig on one side. We can't divide by cosecant of x, which is what lots of people will want to do. It ends up eliminating one of your x's, one of your variables, and you might miss solving for something. So don't eliminate a trig function. So secant x, cosecant x, and then we're going to minus this guy over. It can't combine with these two because this is almost like having a 4x and an... Nope, that was going to come out bad. This is like having a xy and then another y. I can't combine them because they're not the like terms. So just keeping them separate like this, but they do each have a cosecant. So I'm going to take that out, kind of like reverse distribution. Secant x minus 1. So this is almost like having like 4x and another x, and I'm taking the x's out and writing what's left in there. So if I were to distribute this, cosecant times secant would give me that, and then cosecant times -1 would give me that. So I'm kind of doing a reverse or distribution. I'm kind of pulling out what they have in common, which is that cosecant. And we've done these kind before where I end up with like two factored forms, and we set them each equal to 0. So cosecant equals 0, and then secant of x equals 0. Now we're just going to solve them as they were two separate problems. The tricky part is that now we're dealing with cosecant and secant, which are the reciprocals of our trig functions, and they aren't technically on our unit circle. But I'm going to flip them here so that I know what I'm dealing with. So cosecant, I'm going to put that over a 1, and cosecant is the flip of sine, so that means that the sign is 1 over 0, which means undefined. So I am looking for places where the angle for sine is undefined. Next, I'm going to do the secant one, so I'm going to add 1 to the other side. So secant of x equals 1. I'm going to put that over a 1 so that I have a fraction to flip. And secant goes with cosine. So cosine is, and I'm flipping this, although you can't really tell because it's still 1 over 1. So I'm going to be looking for all the places where cosine is 1. So looking around my circle for a place where sine is undefined, where the y value does not exist, it doesn't happen. So I don't have any answers over here. Whereas the cosine 1, that happens at 0 or 2 pi. Next one has 3 parts to it. I've got a cosine squared, then a normal cosine, and then a 1. And anytime there are 3 parts and these two guys do not match in power, we are going to be factoring. So yes, you can factor trig functions. Starting off the 2, I'm going to have a 2 cos to begin, and then a cos over there. The only way to get to a 1 is with a 1 and a 1, so it's kind of a slick factor so far. Now we just need to figure out where our sines go. On the inside, I'll have a cosine. On the outside, I'll get 2 of them, and I need to end up with a positive, which means I need the bigger value to be positive. So again, just like the last one, once it's kind of factored, we're going to set each of those quantities equal to 0, and we're going to solve them separately and find our values of x. So I'm going to add my 1, divide by 2, so I'm looking at cosines of a half, which we did up above in number 2, and then this one, cosine x equals -1, so I'm looking for all the places where cosine is -1. So using the same answers from above, I get 60 and 300, because this is the same as number 2. And then this one says cosine is -1, and that happens at 180 degrees. So I've got 3 answers total on this problem. 3 more to go. Next, we're going to deal with a secant, which is the flip of cosine. So we're going to solve it as far as we can and then flip it so we can find our cosine value. So secant, square root of 3 secant. We're going to move the 2 over and then divide by square root of 3. So we get 2 over square root of 3. I wouldn't fix the root 3 right now. What I would do is flip it right away. So secant is the flip of cosine. And when I flip this fraction, I end up with square root of 3 over 2, which is very handy because that is all over our circle. So we're looking for cosine values of square root of 3 over 2, which happens at 30 and 300. Next, we're doing a cosecant. So I'm still going to add the 4 and divide by 3. So I'm going to end up with cosecant squared equals 4/3. In order to get rid of the squared, we're going to have to square root. And remember, you have to add the plus or the minus. So I'm going to have square root of 4 and square root of 3. So just simplifying a touch, the square root of 4 is 2, and then square root of 3 will just leave. And again, this isn't reciprocal, so we want to flip it. Cosecant goes with sine, plus or minus, and we're going to flip this fraction, so we've got square root of 3 over 2, which is handy because that's everywhere on our circle. And we're looking for every value of sine, positive or negative square root of 3. Sorry, square root of 3 over 2. And that happens lots of places. 60 degrees, 120, and 240, and 300. Last one, cotangent. So doing, darn it, cotangent equals -1. Putting that over a 1. Cotangent is the flip of tan, so I'm going to flip that. And although you really can't tell because -1 over 1 is still -1, I'm just looking for all the places where tangent is -1. That happens twice. Happens at 135 degrees and at 315 degrees. So just doing some solving today. Started off kind of with your instincts, what you would move first, what you would get rid of, and then you're going to start looking around your circle for all the values that match whatever you found.